On the morning of May 25, 1979, an American Airlines McDonnell Douglas DC-10 with registration November 110 Alpha Alpha took off from Chicago O'Hare en route to Los Angeles. Just as the aircraft had initiated its V10 takeoff roll, the left wing engine separated from the left wing, which severed hydraulic lines, retracting the flaps in the process. The loss of lift and thrust on the engine's left side put the aircraft into a nose-down, left attitude roll that continued until the plane impacted the ground, just a few hundred yards from the runway. The crash would claim the lives of all 13 crew members and 258 passengers on board. The resultant safety investigation would reveal that American Airlines personnel had removed and installed the engine during a maintenance procedure, but instead of following the manufacturer's published instructions, chose to execute a time-saving procedure that involved the use of a lone forklift and operator. According to investigators, this procedure caused blunt force trauma to the pylon assembly, which resulted in a critical stress fracture that ultimately caused the separation from the nacelle and ring structure. On April the 28th, 1988, a Boeing 737-200 with registration November Bravo 73711 experienced an explosive decompression during a flight from Hilo to Honolulu, Hawaii. The explosion sheared off the top third of the aircraft's fuselage at 24,000 feet, revealing the front half of the passenger cabin. The aircraft was able to execute an emergency landing, but resulted in the death of one flight attendant and injury to several passengers. The safety investigation would reveal that Aloha Airlines maintenance personnel failed to detect metal fatigue and disbonding of structural joints on the upper fuselage due to lackluster inspection routines that were mismanaged and happened at night. Ultimately, the National Transportation Safety Board would rule that this accident was the direct result of incompetent maintenance work and poor management. So human error. Yes, it's a big problem, causing between 12 and 15% of all accidents involving airliners. Long researched and often misunderstood, human factor studies can be traced as far back as the early 1900s. The bottom line is, mishaps at the hands of maintenance errors are ultimately preventable through the use of focused training and effective management. With regards to the management of human factors in a maintenance program, it's a complex entity requiring a complex approach and understanding. Understanding the unique challenges associated is the first step in the design and implementation of an effective safety culture. With that being said, the creation of which doesn't have to be from the ground up, as maintenance training has been evolving to mirror the precision and analyzation of human factors in the cockpit. Though revised and updated, in 2002, the FAA released Advisory Circular 120.72, which was developed to provide standardized guidance on the establishment and implementation of a maintenance resource management training program for aircraft maintenance teams. MRM training effectively integrates human factor training and was generally designed to mitigate risks in areas where maintenance errors most commonly occur, such as equipment design and manufacturer's documentation and procedure writing, airline procedures and work areas, mechanic training and performance. In closing, according to Yannikides and Sergiu, the International Civil Aviation Organization has firmly stated that in the event of a system failure or breakdown, while human error can be easily identified as the primary culprit, only by conducting a detailed investigation into the hidden human factors can the reasons why the failure occurred be revealed. Knowing the root causes of these failures is critical to the formulation of a maintenance management program that facilitates safe completion of maintenance tasks and the airworthiness of the assigned fleet.